similarly, so in this case, what we are seeing that when we increase the pressure, what is the amount of adsorbate that is getting adsorbed in the adsorbent? So here we have taken into consideration solid adsorbent, but if we talk about adsorption from solution, okay, so we can write the topic in this. Okay, let me go to today's class. Yeah, and here write the topic. Adsorption from solution. Okay, so in this, what is happening, we have some solution, and we have some solute particles, and then we have some solid, and those solute particles are getting sticked into the surface of solid through the solution, from the solution. Okay, so it is not air right now, it is not air, it is what? It is the solution. So in this also you can write the Fredlich curve, that will be, what should I write? Isotherm between x upon m, that means the amount of mass of solute that is adsorbed per gram of the adsorbent, and the equilibrium concentration. Okay, so to make this particular graph, we have x upon m, it will be directly proportional to the concentration and to the power 1 by n, Okay, so concentration to the power 1 by n, and here we can write as it was for pressure. Here we will be having some k into concentration to the power 1 upon n. Okay, if I take log on both sides, then I will have log x upon m, which will be equal to 1 upon n log c plus log k. So in this, the Fredlich curve will be something like this. Right. So this is my C. The intercept, that is log k. This is the concentration. This is the amount of adsorbate on the adsorbent, and the slope here. The slope will be how much? Slope will be 1 by n. Okay, the slope will be 1 by n. Okay, wait a second. This will be log of x upon n. This will be log of concentration, not only concentration. Okay, so similar to the pressure one, but here we have concentration. Okay, इसमें log लिखा था ना हमने? Yeah, log, yeah, correct. Okay, fine. Now write a note. The pressure beyond which adsorption becomes independent of pressure is known as so you have seen one graph now. So here we have seen that when the pressure increases, the adsorption also increases, but slowly it flattens out, right? So see, it has, when it flattens out, so this is the pressure, right? I think this is the pressure. Okay, this is the pressure at which now if I increase the pressure, there is no change in the concentration of adsorbate on adsorbent. So this pressure is known as saturation pressure. Saturation pressure. That means after the saturation pressure, there is no effect of pressure. Even if I increase the pressure, there is no change happening in the amount of adsorbate on the adsorbent, amount of adsorbate in the adsorbent. Okay, so this is known as saturation pressure. Remember this, they can ask you directly, what is saturation pressure? The pressure after which adsorption becomes independent of pressure. Okay, fine. So these are the things about adsorption, absorption, and we have learned these terms. Now we have to start colloidal solution. Okay, colloidal solution. Colloidal solution. Now, in this topic, what we are going to deal with, what happens when we add two things. Okay, when we add something into the solvent. So we have some solvent, and what happens when we add A or when we add B? So when different things are added on in solvent, what happens? Okay, what happens? So I will start this with a question. So here we have three things can happen. If I add something in the solvent, it can either become true solution, or it can be a colloidal solution. This is also known as sol, or it can be a suspension. It can be a suspension. Okay, so when we have A and B inside a particular solvent, when there are two different components, what happens? We can distinguish, we can say that it is either a true solution, or it is a colloidal solution, or it is a suspension. Okay, so here we have A and B. Okay, now I will give you simple example. Okay, I will give you simple example starting meaning so you understand. True solution, when you add, what do you add? When you add salt in H2O or sugar in H2O. Okay, so those examples are of true solution. Suspension, in suspension you can add chalk in water. Then what else? Smoke in air. Okay, smoke in air. So this is a gaseous solution. Now colloidal solution, there is two things that you should remember. You remember milk. Okay, so milk is a colloidal solution. And similarly, if you have fog, not smog, what it is fog. Okay, so fog will be a colloidal solution. These are two examples. Now the most important is colloidal solution, because we are in this chapter, we don't have either true solution or suspension, but these terms have been mentioned in the chapter only in reference with the colloidal solution. Okay, when they are talking about colloidal solution, so they are saying, okay, see, dekho, it is different from solution, it is also different from suspension. Okay, so we'll focus in colloidal solution. How will you say that milk is not a true solution? Why is milk not a true solution? Okay, that is our question. So when I compare milk with salt in water, salty water, or we add sugar in water, if I compare it, then after a while, you can see that in milk, what you can do, from milk, you can extract proteins and all also, right? And also you can see that, I don't know what it is called, malai. All of you know what is malai? When you have milk, na, so on the top layer, there is something thick. So what that is called in English? Do you know? What is the name in English? I don't know what is the name in English. Does anyone know what is the name? Fatima?
No, sir.
Okay, but you understand what I'm saying, what I'm talking about, right?
Yeah, sir.
Yeah, okay. So, and that is why, okay, English is also malai. All right, it's cream. Sorry. Such a easy word, yeah, cream. So there is some cream you can find, right? You can find some cream. And that is why you don't find such property. Aisa kuch nahi hota when you have water and you add salt in it, you don't get anything in the top, right? Anything in the top. So when you first see milk, you can say that, oh my God, this is a homogeneous mixture, true solution. Because when you taste it all, whatever it is made up of, carbohydrate, protein, or calcium, anything, whatever it is present in the milk, you find that it is completely homogeneous. But when you keep it for some time, you can see that there is some cream. So that is why you can separate out that milk is a colloidal solution and true solution is our water. True solution is salt inside water, Okay. Now let us write some more differences between a true solution, a colloid, and a suspension. Okay. So here we'll have true solution. Then we'll have sol or colloid. And after that, we'll have suspension. After that, we'll have suspension. Okay. So true solution, it is homogeneous. Okay. Now, sol or colloid, it is heterogeneous because if you leave for a while, it is heterogeneous in the sense that not all the parts of milk are going to taste same, because if you that cream that gets above the milk, it is going to taste different, right? So this is heterogeneous. And obviously, suspension will also be heterogeneous. This is the first point. Next is the size of particle. Okay, now this is important. Size of particle. Now in this, size of particle is 1 nanometer. Okay, it is 1 nanometer. And in colloid, the size of particle is between 1 nanometer to 1000 nanometer. And in suspension, the size is more than 1000 nanometer. Okay, more than 1000 nanometer. Okay. Now and in true solution, if you pass the salt water through a filter, you will not see any particles, right? You cannot see any particles, right? Particles, they cannot, they will not, what I can say, you cannot filter it, right? You cannot filter it. And in salt, what will happen? In salt, they will get filtered out. If you have cream, they will get filtered out. And if you see in suspension also, they will get filtered out, right? Okay. Next, in true solution, this is stable solution. Colloid is unstable. Now this is stability, and unstability is only relative. And in suspension, we have unstable. It is going to be unstable. Now, there are a few things that I will write here. The first thing is it does not show no Tyndall effect. Colloids, they will show Tyndall effect. And suspension may or may not show Tyndall effect. Okay. Then there is one thing known as Brownian motion. Okay. No Brownian motion. This will show Brownian motion. And this will may or may not. May or may not. Now, here the solute particles are not visible. Visible to naked eye. Okay. And in this, yeah, obviously in this there will be, you can see solute particles. This is what? This is colloid, no? So this is here also it will be invisible. It will be visible. Okay. And yeah, how many points? 1, 2, 3, 1. Yeah. But in this, you just remember this one. This is very important. Size of particle is very important. Okay. So all the differences are fine, but please remember the size of particles is the most important point. This is the most important point. Okay. Now let us talk about some classification on the base of colloids. Okay. Just wait a second. Okay. Just wait a second. Yeah. Then there is classification of that. Before the classification, let me write the definition of colloid, because they can ask you what is colloid. They may not ask what is true solution, because that is not there in this chapter. It is just for the comparison. So what is a colloid? It is a heterogeneous system in which a substance is distributed heterogeneous system in which a substance is distributed in the form of very small particles, okay, very small particles. Very small particle as dispersed phase in another substance called dispersion medium. Okay. Now we have two different words: dispersed phase and dispersion medium. Okay, dispersed phase and dispersion medium. Let's talk about these two terms: dispersed phase. So dispersed phase is the small particle. Okay, the phase of colloid particle, these are known as dispersed phase. Okay, so like you have solute in the solution now, so dispersed phase is like solute. So this is what the phase of colloid particles Okay, please remember this is just like solute in the solution. So these are like solute particles. Okay, next what do we have? Dispersion medium. The dispersion medium is so when we are adding the dispersed phase, so whatever substance we are adding the dispersed phase on, it is known as the dispersion medium. Okay, so the medium in which dispersed particles are dispersed is called dispersion medium. The substance in which the colloid particles are dispersed. Are dispersed. So this is dispersion medium. This is dispersion medium. Okay. Next we have classification of colloidal solution. Next we have classification of colloidal solution. Now let me get your NCERT because there's a diagram that I want to explain from NCERT. It's the 5th chapter, right? Okay, please look here. Okay, so this is what dispersed phase dispersion medium है ना, तो ये आप ऐसे याद रखिए. This is what, this is my solute and this is the solvent. Okay, this is solvent. So when we have solid and solid, this is known as solid sol. When you have solute which is solid and the solvent which is liquid, it is known as sol. Now when you have, see, this sol word is same here, solid sol, and the sol is what, solid inside liquid. So this is what solid inside liquid is our general or usual case, that is sol. When you add solid to solid, it will be solid sol. When you add solid to gas, it will be aerosol. Can you remember this? Yes or no? Tell me. Can you remember this, guys?
Yes, sir.
Hana? So when you have solid in liquid, that is our usual case, that is sol. So when solid and solid is there, then you have solid sol. When solid is there inside gas, it is known as aerosol. It is known as aerosol. Okay, aerosol. Then when we have liquid inside solid, it is known as gel. Liquid inside liquid is emulsion. And again, when you have liquid inside gas, it is known as aerosol. It is again known as aerosol. Okay. Next we have gas and solid. So as you can see, gas and solid will be solid sol because our dispersion medium is solid here. Okay, our dispersion medium is solid. And when we have gas inside liquid, it is known as foam. Gas inside liquid is known as foam. So you have to remember this, in which you have to remember three things which are more important: emulsion, okay, foam, okay, emulsion and foam. These are important. And then you can see that liquid inside solid. Okay, you have to, this is different because this also you have to remember gel. Liquid inside solid is gel, and if you have liquid, it is emulsion. And if you have gas inside liquid, it will be foam. Gas inside liquid will be foam. Okay. When you have dispersion medium as gas, it will be aerosol. When we have dispersion medium as gas, here also you can see it is what, aerosol. When the dispersion medium is solid, it will be solid sol. When you have dispersion medium solid, it will be solid sol. Okay, it will be solid sol. Anything else, guys? Please tell me. I don't think you have any doubt, right? ये 3 numbers याद करके रखिएगा आप लोग. With foam one, gas inside liquid will be foam. Gas inside liquid will be foam. Okay. You guys can remember this now. याद करना पड़ेगा आपको. Okay, you have to remember this. Like you have to spend some time. You have to write this down, and then remember these things. That solid will be solid. They will ask you to identify. Okay, what type of colloid will be formed if the dispersed phase is solid and the dispersion medium is also solid. Okay, so they can ask you this type of question. Next, now this is classification on the basis of what? Classification on the basis of the physical state of dispersed phase and the dispersion medium. We are talking about the physical state, that is solid, liquid or gas. Now next is the classification, that is on the nature of interaction between. We can write classification on the basis of interaction between dispersed phase and dispersion medium. Okay, and dispersion medium. So there are two. Number one is leophobic. Leophobic salts. Leophobic salt means leophobic colloids. Now in this, the dispersion phase and dispersion medium, they don't have any affinity. Okay, they don't have any affinity. No affinity between. Affinity means what? Affinity is a good word for attraction. Okay, no affinity between dp and dm. That is why it is leophobic. That is why this is leophobic. Okay, these are leophobic. Okay, these are difficult to prepare. Require stabilizing agents. They require stabilizing agents. Okay. Next is examples. The salts of silver, gold, FeOH whole thrice. Okay, etc. Okay, and these are also known as extrinsic colloid, aka extrinsic colloid. Then after leophobic, we will have leophilic. They will be just the opposite. Okay, leophobic and leophobic are just the opposite. Then we have leophilic. Leophilic salts. Good affinity between dispersion phase and dispersion medium. Dispersion phase and dispersion medium. Easy to prepare, right? Easy to prepare. These are self-stabilizing. These are self-stabilizing. These are self-stabilizing. It will be strong. Attractive force between dp and dm. Again, right? There will be strong attractive force. Then you can write intrinsic colloids. Example will be gums, gelatin, starch. Okay, so these are the example of leophilic salt. Now, then we have classification on the basis of what type of particle. Next classification is
Sir.
Yeah, tell me.
Sir, could you scroll up? Yeah.
You want to write something?
No, you're from the lyophilic.
Are you writing? Faisal?
Yes, sir.
No, I will send you the PDF, no? Yesterday you got the PDF, right?
Yeah,
Send
yeah.
you the PDF. Okay. Next is classification on the basis of type of particle. Okay, on the basis of type of particle. Particle of what? Of dp. So by the name only you can understand macromolecular. Macromolecular. Macromolecular colloids. Okay. Let us write some points here. Okay. So macromolecular, what does it mean? Macromolecular means the macromolecular or macromolecules. That means big molecules will be there. Those big molecules, they will be in, if you add them in some suitable appropriate solution, appropriate solvent, they will form solution. Okay, they will form solution. But the size of these macromolecules, but the size of these macromolecules, they will fall in the colloidal range. They will fall in the colloidal range. So they form solutions with suitable solvent. Okay, so they are forming solution, but what is the difference here? The difference is that they're forming what solution, but the size is in colloidal range. That means it is between 1 nanometer to 1000 nanometer. Even though they are forming solution, these are known as macromolecular colloids. These are known as macromolecular colloids. Why? Only due to the size. Only due to the size. You understood this? Yes or no? They form solution. They will form solution. They are not forming colloids. But that means they are not forming colloid. It does not mean that they're not forming colloid in the sense that they are stable. And colloids are unstable, but those will be stable. They will show no Tyndall effect. Okay, they will show no Brownian motion, and they will be okay. They will be not visible. It is also invisible here. But the only thing is that they lie between the range 1 nanometer to 1000 nanometer. Okay, so the solution in which solute particles are in the colloidal range are known as macromolecular colloids. Okay, you can also write solutions in which the solute particle, the solute is in colloidal range. Okay, these are in colloidal range. Now, second point. Now, since since these are what? Since these are solutions, they will be stable, right? And they will be stable. These are stable and resemble true solution. And they resemble what? They resemble true solution. Example would be you have starch, okay, then proteins. Okay, so these are what? If you add starch in something, if you add protein in something, they will dissolve, they will act like, they will resemble true solutions, right? They will resemble true solutions, but they are known as macromolecular colloid. Next is, second is multimolecular colloid. Multimolecular colloids. So multimolecular means what? There will be a large number of atoms, right? Or a large number of molecules will be added in the substance. Okay, so multimolecular means so in this type of colloid, what will be there? Large number of atoms or molecules of a substance. A large number of atoms or molecules of a substance on dissolution. That means we are dissolving it in dissolution. A large number of atoms or molecules of a substance on dissolution aggregates and form new species, I can say, and form species which are in colloidal range. Okay, so what do we have? We have small particles, and these molecules, this will be less than 1 nanometer. Okay, this will be less than 1 nanometer. The size will be less than 1 nanometer. Okay, so we have very small particles. Now this is not lying in the colloidal range, but what happens? They, on dissolution, they aggregate together, and now this particles, okay, a large number of atoms, they aggregate together, and this is now what? This is between 1 nanometer to 1000 nanometer, and they, now this new species, and after aggregation, this is now in the colloidal range. This is now in the colloidal range. Okay, so these type of colloids are known as multimolecular colloids. Okay, so when you add the simple molecules, they are not in the colloidal range, but when you add a large number of atoms or molecules less than 1 nanometer, they will aggregate together, and they will come together, and they will be forming colloidal solution, because when they aggregate, those diameter, those species diameter is now 1 nanometer to 1000 nanometer. That is in the colloidal range. That is in the colloidal range. Okay, now examples will be, sulfur. Yeah, sulfur salt consists thousands of S8 molecules. Okay, so many S8 molecules come together, and they form now, they are now in the range of 1 nanometer to 1000 nanometer, and that is why the solution becomes a colloid. The solution, they become a colloid. They become a colloid. Okay, so this is an example. So we have two different types, macromolecular and multimolecular. Okay, so in both of these cases, they will be resembling somewhat what? They will be resembling somewhat true solution, but they are colloid only due to the size, Okay, this is a classification. Next, right, associated colloids. Third is associated colloids. So these type of colloids, so they behave as true solution. Okay, they behave as true solution. That is, they are strong electrolytes in low concentration. In low concentration, but at high concentration, they form, but at high concentration, they behave as colloidal solution. Colloidal solution. Okay, so the only difference between associated colloids and the multimolecular is that multimolecular will be covalent compounds, and associated colloids, they will be electrolytes. Okay, these will be electrolytes. Examples will be soap, and if you add very little soap, right, then it will seem like what? It will seem like a true solution when you, but if you add more and more soap in water, you can see that it is now as colloid. Also detergents. Okay, these are the example for associated colloids. Okay, these are the example of associated colloids. Got this? Yes or no? Please tell me. Three different types, right? Three different types. So associated colloids. Okay. Now, okay, I have to check this. Wait a second. Okay, let us write the topic, that is Tyndall Effect and Brownian Motion. ये दोनों पढ़ाना है आप लोगों को. Okay, can't take this. Properties of colloids. Okay, properties of colloids. I need a image. Tyndall Effect. What is this? I can't copy that image. Not the photo, I think. What's the source of this photo? This is the first topic is Tyndall Effect. Tyndall Effect. So this is a true solution. This is a true solution. This is a colloid. Now, so can you see the difference? What is happening in true solution and what is happening in colloid? Tell me.
So in true solution, the light is not scattered, and in colloidal solution, the light is scattered.
In both the case, the light is scattered.
No,
In which it is scattered? Tell me then.
colloidal solution.
Colloidal solution, the light is scattered. Okay. So this is the basic thing that you have to remember about Tyndall Effect. Right? So what is Tyndall Effect? When when light is passed through a colloidal solution, then what happens? Then all the complete colloidal solution, it will illuminate, right? It will illuminate, and you can see that there is a scattering of light. Okay, scattering of light. This is known as Tyndall Effect. Okay, this scattering of light is not. It is known as Tyndall Effect. Okay, so let me first write what is Tyndall Effect, and the reason of Tyndall Effect is scattering of light in colloidal solution. So let us write here. When a strong converging beam of light, strong converging beam of light is passed through colloidal solution, the path of the beam, what happens? It gets illuminated with the light. Illuminated, and also you can see that there is a tint of blue color here, right? Yes or no? There's a tint of blue color, right? So illuminated with the light. and viewed at the right angle to the direction of the passage of light. Okay. So this whole phenomena is known as this illumination, this illuminate with the light. It is known as Tyndall effect. Okay. The phenomena is known as and why does it happen? It happens due to scattering of light. Okay, it happens due to scattering of light. Okay, now there is another topic which is known as Brownian motion. Okay, another thing which is known as Brownian motion. In your school or somewhere else, like even in your home, you must have seen that when there are windows like this, when the window is closed, right? When the window is closed, but the window, it is not very properly closed. A little beam of light is coming through a hole, or there is some space between the that is present, and sun rays are coming from that portion, like very small beam. Have you seen that? Yes or no? Tell me. Like a beam of light
Yes,
coming
sir.
through. है ना? थोड़ा सा खोलने पे you will have, like if you open it a bit, or if there is some hole somewhere, right? So sunlight, it comes. Then can you see the dust particles moving here and there?
Yes, sir.
That is Brownian motion. Got it?
Yes, sir.
Okay, what is Brownian motion? The zigzag motion, right? The zigzag motion of colloidal particles in the dispersion medium is known as Brownian motion. Detail what you will do, you will write in detail about Brownian motion from your NCERT. Okay, the simple definition समझने के लिए क्या है? It is the zigzag motion. The zigzag motion of colloidal particles in dispersion medium is called Brownian motion. Called Brown. Wait a second. This is Brownian, capital Brown. Okay, Brownian motion. Named after Robert Brown. Okay, named after Robert Brown. This is Brownian motion. Okay. So that is it in surface chemistry. Okay, that is it in surface chemistry. Is there anything else that your teacher has taught you? I think this is the syllabus, right? हाँ guys, नहीं पता नहीं आप लोगों को क्या पढ़ाया टीचर ने. This chapter is done, na? Faisal, Abir, Fatima, Nazira.
Yes,
This
sir. It
chapter is
was
done.
done, but I was not there in the class, so I'm not sure about it.
You're not sure about it. What about Fatima? Fatima is not here or what? Fatima?
Sir, what did you ask?
Asking, this is it in surface chemistry, right? The teacher has not taught anything else.
We studied the last part, no? Their applications.
Application of adsorption. Oh, okay, fine. So
Then that coagulation of lyophilic salts, then protection of colloids. We did that
okay.
also.
So you did that also, protection of colloids and coagulation, electrophoresis also.
Yes.
Oh, okay. Electrophoresis will be there. Okay, and application. Okay, fine then. And fantastic. There are few things that we will do. Electrophoresis. I'm just writing the topic now. Okay.
Then charge on colloidal particle side. We just read through it. Like a
Yeah, this is in electrophoresis only. This will be in electrophoresis only. Okay, electrophoresis we have to deal with, and coagulation. This is I have to explain. Application आप लिख लेना इससे, ठीक है? NCERT से. So in application, what you will have masks, right? This is one of the application that is you cannot forget. You cannot afford to forget about mask. Okay, mask. Then there is production of vacuum. Then there is catalysis. Then I think humidity is also controlled by adsorption. Humidity control. Okay. Chromatography will be there. Okay. So these applications, you write them down. I will explain it. Okay. I think I have to make some slide for this then for application. Okay. And what else? Is there anything else, Fatima?
the last topic, no, colloids around us.
Colloids around us.
Blue
Okay.
color of sky, food articles, blood, soil. That one.
Stability of colloids भी होगा ना फिर तो. Lights around us. Okay. Okay, fine. Okay, then I think this will be done in the next class. और आपकी next class का भी time है. I am not present till 23. 19 and 20 you will have. I will not take class, and then 23 I am coming back. So you will have class on 26, 27. Okay, 26, 27.